All right, so in this video, we're going to go through sample question 57 from the Society of Actuaries ExamP list of sample questions. The question reads, an actuary determines that the claim size of accidents is a random variable x with the following moment generating function of 1 over, then in parentheses, 1 minus 2,500 t, and then a fourth power on the outside of that parentheses. We need to calculate the standard deviation of the claim size for this class of accidents. Okay, so this is a simple question. However, it's good because it tests you on a lot of different facts. So what are we asked to find? We're asked to find the standard deviation, right? So standard deviation of this claim size, right? Now, what is standard deviation? Well, standard deviation is the square root of variance. Okay, so if we find the variance, we can find the standard deviation by taking the square root. So how do we find the variance? Well, what is the variance equal to? You have a couple of different notations, but here, the one that will be useful will be variance is equal to the expected value of your second moment, which is expected value of x squared, minus, that should be an equal sign, minus your first moment, so the expected value of x squared. All right, that formula should just be ingrained in you. Okay, so then how do we get each of these? We're only given the moment generating function. One crucial fact about a moment generating function is if you take the derivative, the first derivative of a moment generating function, and evaluate it at 0, you will get the first moment. If you take a moment generating function, take the second derivative, evaluate it at 0, you get the second moment. If you take the moment generating function and take the nth derivative of it, evaluate it at 0, what you will get is the nth moment, the expected value of x to the nth power. And that's all this question uses. So let's go about finding our first and second moments. In order to find our first moment, we take the derivative of our moment generating function. And I'm just going to rewrite this as 1 minus 2,500 t, and then raised to the negative fourth. That'll be easier to take the derivative of. Here, it's going to be chain rule, right? So chain rule is the derivative of the inside function multiplied by the derivative of the outside function. So m prime x of t is equal to, so derivative of the inside should just be negative 2,500 multiplied by, bring this down, subtract 1, so negative 4 multiplied by 1 minus 2,500 t raised to the negative fifth. Okay, now my job now is to evaluate this at 0. I believe some of this can be cleaned up a little bit. Not too much to worry about. So evaluating this at 0, I'll multiply the negative 2,500 and the 4. Negative 2,500 times negative 4 is 10,000. Yep, that's 10,000. And that's 1 minus 2,500 t raised to the negative fifth. Plugging in 0, this will just be 1 to the negative fifth, right? 1 minus 0 to the negative fifth. 1 to the negative fifth is just 1, meaning my first moment, my moment generating function, the first derivative evaluated at 0, is equal to 10,000, which is e of x. Okay? That one. I'm kind of halfway done, right? Now I'm going to take the second derivative, which I'm going to use this function right here. And I have an inside and outside, and that's going to be, so let me just rewrite this. First derivative is equal to 10,000 times 1 minus 2,500 t raised to the negative fifth. And second derivative is going to be equal to the derivative of the inside thing, which is negative 2,500, multiplied by the derivative of the outside thing. I bring this negative 5 down, and that becomes negative 50,000, I believe. This has one too many zeros. Negative 50,000 multiplied by 1 minus 2,500. Right, 1 minus 2,500. Again, too many zeros. Raised to the negative sixth. Okay. Now, once we have that, I'll kind of clean it up a little more. So that's going to be 50,000, or negative 50,000 times 2,500, and that looks like a very large number. So that's 125,000,000,000, 125 million. And that's multiplied to 1 minus 2,500 t raised to the negative sixth, evaluating at 0. Will just leave us with 125 million. Right, because plugging in 0 here should get us 1 minus 0 to the negative 6 with just 1. 1 times 125 million is 125 million. And that's our second moment, e to the x squared, right? As opposed to e to the x squared. So I'm going to just grab a separate sheet and just start plugging in numbers. So my variance, right, which is the next step, I found these two components. Now I'm going to go here, is expected value of x squared, e to the x squared minus e to the x squared. And this is going to be equal to the 125 million minus, what was my e to the x? I kind of lost it. 10,000 squared. All right, and I'm just going to plug that into the old TI-30, the definite recommended calculator for this exam. And I get, let's see, that is equal to 25,000,000,000, 25 million. And that's the variance. Now, once I have the variance, I square root it to get the standard deviation. And square rooting this, you get 5,000, which lines up with answer choice B. Okay, so not a difficult question in terms of the work you have to do, or even difficult conceptually. This question's difficulty lies in just the different thing it involves. You need to know a few different facts. And it's really good. This is a really good question for reminding you of that, right? These three things need to be so ingrained in you. So what is it asking for? Standard deviation. What does it give us? Moment generating function. Okay, well, what do I know? I know based off the moment generating function, I can get each moment, right? And that's determined by this. You take the nth derivative of a moment generating function, you'll get the nth moment. The variance of any random variable is the second moment minus the first moment squared. So I use the moment generating function. The first derivative evaluated at 0 gets me my first moment. The second derivative evaluated at 0 gets me my second moment. I can then find the variance. Once I have the variance, standard deviation is the square root of the variance. And then I got to my answer. Right? You see, so I'm going from here to here to here to here to here. And that should be pretty much it. If you have any questions, throw it down in the comments. So I'd love to clarify any portion of this if I can. If you want to see more worked out problems like this, I have a playlist. Sample question from the Society of Actuaries, right? Just done out like this. If this video helped you out, hit the like button, subscribe. Please, that definitely helps me out. But other than that, good luck.